We have landed rovers on Mars. We have dropped a probe into Saturn's clouds. We have photographed Pluto up close. But there is one place humanity has only reached twice, the true edge of our solar system, the wall where the sun's influence ends and the dark between the stars begins. Two tiny probes from the 1970s went there, and what they found made no sense. A wall of fire, a hum that never stops, data that came back scrambled from 15 billion miles away. NASA publishes the numbers, but the anomalies are real, and they are still unexplained. Subscribe and let's follow Voyager past the edge. The story begins on a launch pad in Florida, summer of 1977. Voyager 2 lifted off on August 20th. Voyager 1 followed on September 5th. Each probe weighed about 720 kilograms, roughly the mass of a small car, and each was designed to last just 5 years, long enough to fly past Jupiter and Saturn. That was the whole mission. Take some photos, send them home. Die quietly. But the engineers at JPL built these machines a little too well. Nearly 50 years later, both probes are still alive, still transmitting, and now more than 15 billion miles from Earth. A radio signal from Voyager 1 takes over 22 hours to reach us. They are the most distant objects human hands have ever touched. And in 2012, one of them did something no machine had ever done before. On August 25, 2012, Voyager 1 crossed a line that no human machine had ever crossed. It exited the heliosphere, the vast bubble of charged particles blown outward by the sun, and entered raw interstellar space. Think of the solar system as a giant soap bubble drifting through a windy room. Inside the bubble, everything is warm and lit by the sun. Outside, there is a cold ocean of gas and dust left over from dead stars. Voyager 1 punched through the skin of that bubble. Scientists at JPL confirmed the crossing months later by watching the particles around the probe change from solar to galactic. It was the first time anything built by human beings had ever left home. But the crossing itself was not clean. Just before the edge, Voyager hit something the engineers had not prepared for. In the months leading up to the crossing, Voyager 1's plasma science instruments recorded something almost impossible to picture. A layer of charged gas heated to nearly 50,000 degrees Celsius, hotter than the surface of most stars. This is the outer wall of the heliosphere, a place where the solar wind slams into interstellar gas and compresses into a searing barrier. The probe had to fly straight through it. Now, here is what saves Voyager. Plasma at that temperature is incredibly thin. There are so few particles per cubic centimeter that a spacecraft can pass through without melting, the way you can wave your hand through the flame of a candle if you do it fast enough. But the readings still stunned mission scientists. A wall of fire, tens of thousands of degrees, marking the edge of everything we call home. And on the other side of that wall, the numbers got even stranger. Every model said the same thing. Once Voyager crossed into interstellar space, the density of particles around it should drop. Outside the bubble, further from the sun, the gas should be thinner, emptier, quieter. Instead, the plasma got denser, significantly denser. In 2013, and again in 2020, the University of Iowa team led by Don Gurnett published measurements showing that the electron density outside the Heliopause was actually higher than inside. It is as if you walked out of a crowded room expecting an empty hallway, and instead found the hallway even more packed with people. Nobody predicted this. There are theories, maybe interstellar gas piles up against the outer skin of our bubble like snow on a windshield, but no one can fully explain it. And then Voyager began to hear something. In May 2021, Cornell University astronomer Stella Ocker was combing through Voyager 1 telemetry when she noticed something no one had heard before. A faint, steady signal in the plasma wave data, not a burst. Not a flare, a constant narrow hum hovering around 3 kilohertz. It was the sound of interstellar space itself. When plasma vibrates, it produces waves that instruments can translate into audio. What Voyager was picking up was the drone of the galactic medium, the quiet ringing of the material between the stars. Before this, We only heard interstellar plasma when the sun coughed out a violent solar flare that made it ring. This was different. This was the background hum, always there, always steady, the ambient sound of the dark. And when scientists checked the direction of the magnetic field carrying that hum, they got another shock. Here's what every textbook predicted. When Voyager crossed the Heliopause, the magnetic field should have swung around. Inside the bubble, the field lines come from the sun. Outside, they should come from the galaxy and a completely different direction, tilted by tens of degrees. It would be like walking out of your house and finding that suddenly north was pointing sideways. Voyager crossed the boundary, and the magnetic field barely moved. The direction outside was almost perfectly aligned with the direction inside. In 2013, mission scientist Leonard Berlanga called the result baffling. It is still baffling today. Some researchers now suspect that the interstellar field near the sun has been draped and combed by our own bubble, like hair pressed flat against a wall. Others admit they simply do not know. And then Voyager 2 arrived and made everything more confusing. On November 5, 2018, Voyager 2 became the second machine to cross into interstellar space, but it crossed in a completely different place. Voyager 1 exited through the northern part of the heliosphere. Voyager 2 exited through the southern flank, more than 120 astronomical units from the sun, about 11 billion miles away. And the two edges did not match. The thickness of the boundary was different. The plasma readings were different. The particle behavior was different. Together, the two probes revealed that our solar system is not a clean, round bubble at all. It is lopsided, wrinkled, and constantly reshaping as the sun plows through the galaxy at over 800,000 kilometers per hour. We do not have a map of the edge of our own home. We have two lonely data points taken 40 astronomical units apart, and they disagree. And then in 2022, something worse happened. In May 2022, Voyager 1 started sending back gibberish. Its attitude and articulation control system, the computer responsible for keeping the antenna pointed at Earth, began transmitting telemetry that made no sense. The commands worked. The probe was still flying, but the health data coming back was scrambled, as if the spacecraft had forgotten how to speak. Then, in November 2023, it got worse. Voyager 1 stopped sending usable science data entirely. For 5 months, engineers at JPL, some of them now in their 70s, brought back from retirement because they are the only people alive who understand the 1970s code, tried to reach a computer 15 billion miles away in the dark. Each command took 22.5 hours to arrive and another 22.5 to hear the reply. In April 2024, they finally traced the problem to a single failing memory chip. They rerouted the code. Voyager spoke again, but not for long. Bolted to the side of each Voyager is a gold-plated copper disc, 12 inches across. It was assembled in 1977 by a team led by Carl Sagan. On it are 115 images of Earth, greetings recorded in 55 languages, the sounds of thunder and whale song and a human heartbeat, and 90 minutes of music from around the world. And on the cover, etched in symbols meant to be readable by any intelligence that finds it, a map. 14 pulsars arranged like breadcrumbs pointing directly back to our sun. In the 1970s, this felt like a beautiful gesture. Today, some scientists are quieter about it. Physicists, like Stephen Hawking before his death, publicly warned that announcing our location to the galaxy might not be wise. The golden records are still out there, drifting away at 17 kilometers per second, carrying a signed address to Earth. And they will keep drifting for a very long time. So here's the truth about what is being hidden. NASA does publish the Voyager data. Anyone can download it. There is no secret file, no locked room. But something else is hidden. The answers. The wall of fire. The denser plasma outside. The hum. The magnetic field that refused to turn. The lopsided edge. The scrambled telemetry. Every one of these anomalies is real, documented in peer-reviewed papers, and still unexplained. Both probes are dying, one instrument at a time. Their plutonium-238 power sources lose about 4 watts every year. NASA now estimates that sometime between 2025 and 2030, the last science instrument will go dark. After that, they will drift on in silence for millions of years, past the Oort cloud, into the space between the stars, carrying a golden map of Earth. And the questions they raised at the edge of the solar system may never be answered, because we will never send another probe far enough in our lifetimes to check. 2 machines built by people who mostly no longer live, running on code older than most of us, are the only eyes we have on the edge of our own home. And what they saw does not match what we thought we knew. In a few years, they will fall silent, but they will not stop. They will keep drifting, carrying our voices past a boundary we may never study again. So, tell me in the comments, if we could build one more probe to answer just one Voyager mystery, which would you choose? The wall of fire, the hum, or the magnetic field that refused to turn?